In this video, I'm going to demonstrate the installation and configuration of a Bootstrap machine. The deployment of the Tanzu Kubernetes Grid management and workload clusters is essentially facilitated by setting up this Bootstrap machine, where we are going to install the Tanzu CLI and the kubectl utilities. These utilities are used to create and manage the Tanzu Kubernetes Grid instance. This Bootstrap machine also keeps the Tanzu Kubernetes Grid and Kubernetes configuration files for your deployments. The Bootstrap machine can be a laptop, a host, or a server running on a number of operating systems including Linux, macOS, or Windows that you will then use to deploy the management and workload clusters from. In my environment, I'm going to import a Photon image into our vSphere environment and use that as the Bootstrap machine. A quick overview on the process here. So the Bootstrap machine runs a local Kubernetes in Docker or kind cluster locally when the Tanzu Kubernetes Grid management cluster deployment is started. Once the kind cluster is fully initialized, the configuration is used to deploy the actual management cluster on the back-end infrastructure, and this will deploy the VMs required in vSphere, AWS, or Azure. And after the management cluster is fully configured, the local kind cluster is deleted and future configurations are performed with the Tanzu CLI. So there are a few prerequisites to keep in mind. The Bootstrap machine needs at least a minimum of 6 GB of RAM and a 2-core CPU, and it needs to have Docker and the containerd binaries installed. In order to start deploying my Bootstrap machine, the first thing I'm going to do is log into the vCenter. Once logged in, I'm going to deploy my Photon VM by right-clicking and selecting Deploy OVF Template. A window will appear asking for a number of configuration parameters. I'm going to use a publicly available Photon image, which you can download by following the link below. The link will take you to a publicly available page on GitHub, allowing you to download different revisions of Photon OS. So the one we are interested in is this one, which is the OVA with virtual hardware v11. So I'm going to copy the link for this image. I'm then going to paste the image in the URL field and click Next. A window will appear asking if you wish to trust the source. Click Yes. And we can now select a name and a folder for this machine. So I'm going to call this Photon Bootstrap, and I'm going to click Next. We then need to select a compute resource, so I'm going to just select the default and click Next. The details for the image will be shown. In order to proceed, we click Next. Accept the license agreement and click Next. We now need to choose the data store where this VM is going to be created. So I'm going to just choose the vSAN data store, which is the only one we have available in this environment, and click Next. We then need to select a network where this VM will be attached to. In this environment, I am going to connect this to the TKG management logical segment. This logical segment has DHCP enabled, so when we start the VM, it should obtain its IP address automatically from the pool of configured addresses. Once you've selected the network, click OK and click Next. And then it will give a summary of the configuration parameters. In order to deploy the VM, let's click Finish. You will now see the status of the VM deployment in the taskbar. This may take a while to deploy, so I'm going to speed it up. You will see the VM is now being deployed and the task is listed as completed. And we can now click on the VM which we've created. Now, you remember I mentioned that we have specific prerequisites for the resourcing. So at the moment, the resources allocated do not match this prerequisite. So we're going to modify those quickly. So I'm going to right click on the VM and say Edit Settings. And then I'm going to change the CPUs to 2, and I'm going to change the memory to 6 gigabytes. Once that's done, I'm going to click OK. And you will see the resources have been changed. So we can now start this VM. The VM will take a moment to boot up and perform some self-configuration, and it should get an IP address allocated to it, which will appear here. As expected, you can see the machine has started, configured itself, and picked up an IP address from DHCP. So we should be able to SSH into this machine now in order to perform the additional configuration. Switching over to a terminal window, I'm now going to SSH into the Bootstrap machine. In this case, I've created a DNS entry for the allocated IP address. So it's going to try and validate the authenticity of the host. We want to connect. And the default password for the root user for this photon image is change me. So at first login, it's going to request us to change the password. So I'm just going to change that quickly. Confirm the new password. And once that's done, we're into the machine. So the first thing we're going to do is just update the packages for this machine. So you'll see there's quite a lot of packages. We're going to update them. This will take a while to download and install. So I'm just going to fast forward this. So once our packages are upgraded and installed, I'm now going to add a user so that we don't use the root user. So I'm going to use the user add command, and I'm going to add this user to the sudo and docker groups. And I'm going to call the user TKO user. That user should be created, and we can validate it by checking the password file. So we can see our user created there. And if we check the group file, we should see that TKO user has been added to the sudo and docker groups. So you will remember that I mentioned that Docker is a prerequisite for this Bootstrap machine. So by default, Docker's not started. So we want to firstly make sure that it starts on reboot. So we're going to set that. And once that's done, we're going to start the Docker engine. So we should now be able to execute Docker commands. So there are a few additional packages that I want to install that aren't installed by default. So I'm going to install those now. And those packages are namely wget, tar, and sudo. So it's going to ask me if I really wish to install these. Yes. So it's going to download those packages and install them. And now we should be able to execute those. So the final bit of configuration we need to do as the root user is add a rule to IP tables. So the TKG installer requires us to bind to a port on this machine, and by default that port is not accessible externally. So we need to add a rule to allow external traffic to be able to hit that port. So I'm going to do that using the IP tables command. So we want to accept any traffic coming in using TCP on destination port 8000, which is the port I'm going to bind the TKG UI to, and we want to accept it. So that should be configured now. And that's all the configuration that needs to be performed by the root user. So I'm now going to switch over to the TKO user, which we created, and we should be able to execute Docker commands because we've added it to the Docker group, and we should also be able to sudo to the root user as required. So within our home directory, I'm just going to make a TKO directory, and in that directory we're going to download the Tanzu CLI and the kubectl CLI. So I'm going to do that using wget. So the first one is the Tanzu CLI, and then I'm going to download kubectl. And those two required packages are now downloaded. So from those packages, there's a number of CLI tools which we're going to extract and then install into the user local bin path. So I'm going to run this command which performs the extract, the install, and changes the mode of the Tanzu binary to execute so that we can run it. So it's going to ask us for the sudo password for the TKO user. So the Tanzu CLI should now be installed, and we can validate that by running Tanzu version, should return the version of the Tanzu CLI. So once that's done, we now need to download the required plugins in order to execute Tanzu commands against specific things like the management cluster. So in order to do that, we run Tanzu plugin sync, and this will download all the required plugins and install them so they can be used by the Tanzu CLI. So you will see here that it's pulled a list of required plugins and it's now installing them. So there's a plugin for login, a plugin for management cluster, a plugin for package, a plugin for Pinniped authentication, secret plugin, telemetry plugin. And once that's complete, the plugin sync will list as done, and we can validate that those are installed by issuing a Tanzu plugin list. And you'll see all of those plugins that it downloaded and installed should all show as status installed, as you can see on the right. So we're now going to install kubectl. And to do that, we'll use a similar set of commands. So we're going to extract the kubectl archive. We're then going to move it into the user local bin path and change the mode to be able to execute that command. So once that's complete, we should again be able to execute kubectl version, and it will return the version of the kubectl CLI. Now the last tools we need to install are the Carvel related tools. So this is the YTT, KApp, KBuild, and image package utilities. And again, I'm going to execute similar commands. So these archives are located in the CLI directory that we extracted. So you'll see them all here. And the command we're going to run is similar to the previous command. So we're going to extract, in this case, YTT. We're going to change its mode to execute, and we're going to move it into the user local bin path. And once that's done, we should be able to execute YTT version. So that's installed correctly. The next one we're going to install is KApp. So similar command. And once that's installed, we should be able to execute KApp version. So that's installed correctly. Next one we're going to install is kbuild, and we'll use a similar set of commands. And if we execute kbuild version, it returns back correctly, so that's installed correctly. And the last one we're going to install is image package. So similar set of commands, and once that's done, we should be able to execute image package version, and that returns back successfully. So those are all the utilities we require in order to proceed with the TKG installation. Now, the final piece of configuration we need to perform is to generate a private public key, and this will allow us to SSH into the control plane and worker nodes for debugging if required. So in order to generate the key pair, we're going to run SSH keygen. And once executed, this may take a while to execute. It's going to ask us where to save the key. So we're going to save it in the TKO user's home directory. I'm just going to leave the passphrase empty for now. And that's our private public key generated. So as you will see from subsequent videos, we will use the public key in the TKG installer interface. So the last thing we need to do is add the private key so that SSH is aware of it. So in order to do that, we're just going to run an eval on SSH agent, and then we're going to run SSH add and the location of the private key, which is our home directory.ssh and id_RSA. So that identity has now been added, and we should be able to use the public key to SSH into the nodes. So that concludes all the prerequisite configuration that's required in order for us to run the TKG installer, and also brings us to the end of this video. So thank you for watching.